Okay, so let's start. Today we are going to learn about, some non-sorted, non-standard binary search. Okay, like this is not majorly used in CP, but for DSA and interviews it is very important. Like you won't find this in competitive like on CodeChef. You won't find much of the questions regarding this, but it is a very favorite question for interviews. So let's see what it is about. So the question name is search and rotated sorted array. So there is an integer array nums sorted in ascending order with distinct values. Okay. Prior to being passed to your function, nums is possibly left rotated at an unknown index k, such that the resulting arrays, and we are giving some format. So let me explain you the question using this test case. Like your array was 0, 1, 2, 4, 5, 6, 7. Your array was 0, 1, 2, 4, 5, 6, and 7. Okay. And what will happen is like some of the numbers from the last. Okay, this whole will come as it is on the front, and this will go here. So what does your array becomes? It becomes like this. Okay. So this is your array. So actually the array like this will be your input array. This will be your input array. It is rotated at some index. Okay, like here it is rotated about 0. So you will see like 4, it is called 4 rotated. Why? Because 4 elements from the last are coming into the front. So that is why 4 rotated array. So as defined in the question. Okay, so now what we need to do is in this array, we need to find whether our integer target exists or not. If it does not exist, we need to return -1. Otherwise we need to return the index of that element. Okay, and the expected runtime complexity is log n. So if you see like the naive approach would be, simply big of an approach, iterate over the whole array and find if you found the number, then return the index. Otherwise, you can simply return -1. And since it is given in the question that the values are distinct, so it makes our job quite easy. Why? Because you will see like here we don't have any kind of monotonicity. So how will we apply binary search? Monotonicity. So how will we apply binary search? Okay. But if you see carefully, the array is divided into two parts. Okay. So there are two sorted arrays inside the array. If you see, like what is this is your array. Okay. And there are two sorted arrays, sub-arrays inside the array. Like this is one sorted sub-array and this is another sorted sub-array. Right. So what we need to do is we need to find the target. And since there are two sorted subarrays, let's see like how we will apply binary search here. Two sorted subarrays. Okay. So let's see how the binary search will go. So suppose this is your array. Okay. And your low will be here initially and high will be here. Okay. So what happens is similarly we take the mid. Now in order to do a binary search, like the standard binary search, we need to know like in which section we are. Okay, so how will we check that? Like we need to know whether the left part, like the part in which part is sorted, like whether this part is sorted, okay, like from low to mid, or whether the part from mid to high is sorted. Only then we will be able to decide, na, like whether we need to go to the left or to the right. How, like suppose here, if you see, the left part is sorted. From low to mid, the array is sorted, but from mid to high, the array is not sorted clearly. Why? Because 7 comes and then after that 0 comes. So the array is not sorted. So we can simply find like which part is sorted, by checking like if ARR low is less than ARR mid, then simply we can see that the array is sorted. the left part is sorted. And if ARR mid is less than ARR high, or you can simply say the reverse also, like uh, you can also say like, so you can also say like if ARR low is less than ARR mid, then clearly the array is sorted. The left part is sorted. Left part is sorted. Otherwise, the right part is sorted. Otherwise, right is sorted. Why? Otherwise. Okay. So why we can say this? You will soon understand this, but currently just think of this first case. Okay. Like if ARR low is less than ARR mid, then clearly the left part is sorted. Correct? And we can see this also. Now let's see what is the target value we need to find. Okay. So target is 0. Target is 0. Now, since the left part is sorted, now continue with your like normal binary search. So, what would happen here? If your target, see, whether your target lies between this 4 to 7, you need to check this. Like, here your target is 0. So, does it lie in this array? Like, does your target lie between 4 to 7? Is it less than 4, greater than 4, and less than 7, or is it greater than 7? Now, clearly you can see that since your target is less than 4, so what you need to do? You need to update low to mid plus 1. Why? Because since there are some more smaller elements that are present after mid, okay? So that is why you need to update your low to mid plus 1. So how will it go? Like your low will be updated to, okay? So this happens. Now see what will happen. So why, even though, see, in the standard binary search approach, what would you do? Like, if your target is less than, like, if your target was out of this range, like, if the target was less than low, since your target here is less than low, then it would mean that the element is not present. But here, if you see carefully, since we have some more elements present after mid that are less than low, then that is why we are updating low such that because we need to check this array also, na? And this contains shorter elements like smaller elements. So that is why we need to traverse into this array also. So that is why even though the value is less than the lowest element, like this low, still we are doing low to mid plus one. We are updating low to mid plus one. Okay. So what happens? Now your low is, now this is your low and this is your high. Correct? So now what happens? Now again you calculate the mid. Okay. So mid comes to be 1. So now what is the case? Is low less than high? Error low less than mid. Yeah. So error low is less than mid. Okay. We come into this condition. So your low to mid array is sorted. So search in this sorted array. Now what we'll check? What uh, what we'll check is, like, is the value, is the target, is your target lie between 0 to 1? Okay, so what we'll check is, does your target lies between 0 to 1? And yes, you can see that your target lies in 0 to 1. Okay, so what we'll do, we'll update high such that it comes in this range. Okay, since that we know that the target is between low to mid, now we know this that the target lies here. Target belongs to this range, so simply put low and high minus 1. So mid minus 1. So simply update your high to mid minus 1. Okay, like this is what you have to do. Clear? Why? Because since we know that our target lies in the range from low to mid, so simply you can, update your high to come in this range only because the answer lies somewhere in this range only. So where does your high land? Your high land in this value on low only. Like, This becomes your new array, and this is your low only, and this is your high. Now this time we check if now mid is also this element only. Now if since we'll put a check also here, like if arr mid is equal to target, then simply return the index. Otherwise, we'll keep on searching. Like this check is the first check that we'll be going to put. Okay. So since your low, high, and mid all land on the same value, and we can see that ARR mid is equal to target, then we'll return the index. Okay. Like just as I told you, like what was the template that we used to follow earlier? This was our template. We used to do this now. We used to calculate the mid, and then based on some condition, we either updated low, else we updated high. We updated low to mid plus one, else we updated high to mid minus one. But this is something non-standard. That is why I told you in the beginning only, like this is some non-standard binary search. And you will see, I have never, like personally, I have never seen a single question on Codeforces or CodeChef of, this type of rotated sorted arrays or like this. So that is why this approach is mainly for, interviews where you need to give highly optimized code and to the interviewer. So this is, I would say that is why it is a non-standard binary search approach, and our template also like this template we fixed. This won't work here. Matlab, it would work, but slight changes are there. That is why. So that is the approach. Like what you need to do is, what is the conclusion? Conclusion comes out like first we'll check. First we'll find what is the sorted half. We need to find the sorted half. Then only we can apply. Then only we can check the target in that range. Okay. So first we'll identify the sorted half, and based on the sorted half, we'll see whether the target lies in the sorted half or not. If it does not lie in the sorted half, then we'll update accordingly. Like suppose this was your array, low, high. Okay. And from here to here, this was one of your sorted half, and from here to here, this was one of your sorted half. So what would happen? Like suppose your mid lands somewhere here. So since suppose this is your mid. Now, since we know that this is the sorted part, this part from low to mid is the sorted part. Okay, mid to high is not sorted. Why? Because some value greater and then smaller value starts here. Because this was the rotated sorted array form, na. So that is why from low to mid the array is sorted. Now we'll check whether the target lies in this low to mid. Okay, suppose it lies in this low to mid, then simply you can update high to mid minus one because the answer lies in this range only. Okay, and what happens if the target does not lie? If the target is greater than mid, like suppose whatever it is, it does not lie in this range, then simply you need to check. You need to do low equal to mid plus one. You need to update low to here because some greater values are also possible. Like I'm saying. Uh, okay, so suppose your mid lies somewhere here. Where will your mid lie? Suppose your mid lies here, suppose initially. Okay, and this is your low, this is your high. Suppose this is a condition. Okay. Now what will happen is you will see like this array is sorted. Okay, and your target is suppose target here is suppose what is your target? Suppose your target is 20. Okay. So your this part is sorted. Okay. Now the target does not lie in this range. Like the target is neither greater than target is greater than 10, but it is also greater than 18. It does not lie between 10 to 18. It is greater than 18. Okay. So we need to check further, like for the further part, because after 18, some greater elements are also present, and after 18, some less smaller elements are also present. So we need to go and check into that part. That's why we update our low and make it come here. What happens if it lied between, this low to mid? If it lied between the low to mid, like 10 to 18, suppose it was 14. Okay. If it lies between 10 to 18, then we need to update high and make it come here. Why? Because Since it is greater than 10 and it is less than 18, then definitely it is present in this range only. That is why we'll update our high. And if it is not in this range, we'll update our low. Okay. So that is the reason. Like it is also possible, like not necessarily greater than 18. It may be less than 10 also. Like suppose it was 2 here. Now here it is less than 10. It does not lie between 10 to 18. Still we'll do low equal to mid plus 1. Why? Because we have further some candidate elements that can be checked. That is why we are always if it lies between low to like this range, like 10 to 18, then you need to update high. Otherwise, you need to update the low value. Okay. Uh, yeah, that is the case. This was the case when low to mid was sorted. Okay. Now you can create the complementary case also where mid to high was sorted and low to mid was not sorted. Like some case may arise like, okay. So here you will see this was your low, this was your high, and this was your mid. Okay. So here if you see like your low is greater than mid. So definitely we can say that the part from mid to high is sorted. That is all that is that will always be the condition. So we can definitely say that mid to high is sorted. Now compare your target with this range within this range. Similarly, if the target lies between 1 to 3, then you need to update your low and make it come here. And if the target does not lie between mid to high, so what in that case it may lie somewhere here. Okay. So that in that case you need to update your high and make it come here. So that is the case, and that is why this makes it a non-standard binary search question. Like, let me show you the code also. So this is the code. Initially, similarly initialize low and high. Calculate mid equal to low plus high by 2. Check for mid. Like if nums of mid is equal to target, then simply return mid. Because you will see like some cases arise like where if you don't put this condition, then inside the loop only, then you may miss the answer. That is why. So putting it like this is the non-standard question. So definitely you need to do this, yeah, and you need to put this condition. You will see definitely some test case where this will go wrong. Like you can comment out this and submit the question. Then you will see like some test cases are coming wrong. Like suppose that we do this and show you why some will come wrong. So we'll get the test case. So see here 513. Suppose 513. So this was your low, this was your high. Now this comes out to be your mid. Now we can see that this array is sorted. Okay. So we'll compare our target. What is the target? Target is 1. Okay. So what happens? Target is equal to 1 here. So what happens here? Now if we, commented out that condition, we didn't check like if mid is equal to target. So that is why, so here it ignores that. Okay. So now normal binary search goes, now what would happen? We'll see like if the target lies between 1 to 3. Okay. So yeah, it lies between 1 to 3. Then what will happen? Your low will be updated to this place. Correct? So this comes out to be low high comes here and mid also comes here. So in this case, what will happen? Now low to high. So since this part is sorted from low to mid, like whatever your first condition is, that will run. And in that case, either your low or your I think your high will be updated and high will come here. Okay. But for most of the cases, if you see, our answer was stored in low and it became, and now this time it came in high. So that is why it is better, like if you check it inside this here, inside, while loop only. So that will be better because, in this way you can avoid some, what do I say, extra bugs. Like you can see what is the low and high that is coming here. So let me run this using this test case. I think, hmm, yeah. So see, in most of the cases, low was giving the correct answer because see, I have outputted low here. See, when I am returning, your low is 3 here and your high is 4. Yeah. So, oh, so sorry, I have done reverse like this manner. Low here. and high here. So yeah, so see here. Like your low is 4 here and your high is 3 here. 0, 1, 2, 3, 4. So correctly, the low pointed to the correct element here. Low pointed to the since what is the target? Target was 3 and it was not found. So low was not pointing to low was pointing to an incorrect index. That is why -1 was returned. Similarly here, so you can see like here low gives the correct answer and here high gives the correct answer. This is happening because some edge cases are arising, like where high may also give the correct answer. So either you need to check that condition also here, like simply put another condition. If high is within the ranges and if high is equal to target, then return the index of high. Or otherwise, I think it will be better like if you put a condition directly here. So that is the reason. When you submit it this time, it will submit. So you can see. So that was, one of the, what I say, like one of this search in rotated sorted array, one of the variation I would say. This was the basic. Let's see another variation in this question only. So similarly here also the integers in the array are distinct. Okay. And since they are distinct, what we need to find is we need to find the smallest element. So what will be the smallest element of this array that is given that the this rotated sorted array? So rotated sorted array smallest element. So since this was your array before it was rotated. Okay, this was your array and after it is rotated, it becomes this. So inside the array, what is the minimum element? Minimum element was this initially, and this shifted to a position ahead. So we need to find this element, okay, correctly. So this is the question. We need to find the minimum element of the array, okay. So actually, if you see, we need to just find the pivot element. What do I mean by pivot here? Pivot means that just after this element, like just after this element, the array is sorted, and just before this element, the array is unsorted. For this, okay. So you can see, like for this element, after this, the array is sorted, and before this, if you see, the array is unsorted. If you take this element and start taking, the array is unsorted, and if you start taking this element and take elements ahead, the array is sorted for it. Okay, like this. This arrays, these arrays are sorted, and these arrays are unsorted for it. Okay, so this is the pivot element. We need to find the pivot element. Okay, so how we will do that? Uh, for that, here also binary search may apply. Why? Because we have two sorted subarrays, so some kind of monotonicity is there. We just need to do some trick to find this pivot. So how we'll do that? Let's see. This was your array. Okay, your low is here, your high is here. Now we know definitely that the array part, like the subarray part, which came to the front, contains the element always contains the element that is greater than the this element, largest last element. Okay, so you can see that whatever the part was that came to the front, definitely it is greater than the last element of the array. Like some case may arise like the where the array was sorted only. Like this case may arise, but apart from this case, you may see like always it will happen like even if one element comes to the front. So suppose this was your initial array before rotating. Okay, and after rotating it became this. So you will always see that the last element is always less than the first element here. Okay, and subsequent elements also. So you will see like the last element here is smallest than the first element here. And for some elements it may happen. So for those all of those elements where the last element is smaller than that element, and that is behind last element. Like what I am saying here is I am saying for all of these elements, the last element of this array is smaller than them. And for other elements, the last element is greater than them. Okay, so that will be our approach. Like we can simply check the pivot, like we can how we'll check the pivot for all of these elements, for all of these elements where the last element is smaller than them, then pivot lies to the right. And for all of those elements where the last element is greater than them, the pivot lies to the left. Okay, for one you can see, or for zero, you can suppose there was like this was three and this was two. For two also you will see like the last element is greater than two, so the pivot lies to its left. So that will be our approach. Like if mid comes on an index where it is greater than the last element, then definitely the pivot lies to the right. And if it happens like if our mid comes on 1, and since 1 is less than the last element, then definitely the pivot lies to its right. So that will be our approach. So what happens here is you can take any array, and because even if the array is completely sorted, suppose this was your array, you may think like in this it won't work, but it will always work. Why? See, let's suppose mid comes on this element. Okay, this is the mid. Now you will see like the mid, this value is less than the last element of the array. Okay, so that means the pivot lies to the left. Okay, and since the whole array is sorted, this is the pivot element. Okay, so what we need to do is, and for if suppose like here you saw. Okay. So here you saw, like, if the mid comes on 10, since 10 is, smaller, greater than the last element, so definitely the pivot lies to the left. So that is the case. And, it is a very simple question of just finding the minimum. And, here our standard template also gets follows easily. So this is the case. Simply initialize low and high, find the mid. And if mid is greater than the last element, like nums.back gives you the last element. If the mid element is greater than last element, then the pivot lies to the left. So we do low equal to mid plus 1. Otherwise, the pivot lies to the right. Uh, oh, sorry. I just spoke the reverse. Like if the mid element is greater than the largest element, then the pivot lies to the right. And otherwise, the pivot lies to the left. Okay. And finally, you can return nums of low. So that is why all the test cases will pass. You can see also. Yeah. So you can see that. What is the other kind of variation here? Like here, what is the case is like it is same as the first question. Just as we did the first question, what we need to do here is rotated sorted array part. Okay. So what happens here is you are given similarly a rotated sorted array, but the only extra condition here you are given is the elements are not necessarily distinct. Okay. In the first question, where we wanted to find some target, like whether it is present or not. Now, we were given that all the array elements were distinct, but here you are given that all the elements in the array are not necessarily distinct. So let's see how will that cause any problem. So suppose what is the array? 2560012. I don't think this will cause problem, but let me give you a test case where it will cause a problem. Okay, so suppose this is the case, and case number two is this. Now see both of these cases, the target is one in both of these cases. These are two separate arrays, like two separate test cases, but in both the test case, the target given to you is one. Okay, so see this carefully. Here is your low, here is your high. Okay, so what is the mid? Like it is somewhere, I think, over here, over here. So this is the mid. Okay. And in this case, what is the mid? Suppose this is the mid. And the target is 1 in both the cases. Like this is the mid here and this is the mid here. Okay. So now think carefully. What we were doing in the first question, like we were first finding what is the sorted part. Okay. So let's see what is the how will you see what is the sorted part? You used to check like if nums of low is less than equal to nums of mid, then definitely the left part is sorted. But see here, in this case, see here, even though the low is less than equal to mid, like nums of low is less than equal to nums of mid, still the left part is not guaranteed to be sorted. Okay, so that is the reason here. Like since in the earlier test cases, what were happening is here if it was 2, then definitely 2 cannot come here. So that is why 3 or 4, something like 3, 4 will come here. In the first, if it was the first question, since the elements were distinct, if here it was 2, then definitely 2 can't come here. So element must here be greater than 2. So here we can easily find out whether this range is sorted or not. And since it is 3 here, we can find like this range is not sorted. But since the array elements are allowed to be same here, since the elements are allowed to be same here. Now you can't decide seeing only low and mid that whether this left subarray is sorted or whether this less left subarray is sorted not sorted. Okay. So what to do in this case? Because suppose the target was 1. Now if we are not able to find out what is the sorted range, like whether low to mid is sorted or whether high to mid to high is sorted. If we are not able to decide that, how will we check like where to move to find one correctly? Suppose if you think okay now low is less than equal to mid like 2 2 and one doesn't lie from 2 to 2, so we just update low to mid plus 1. Suppose you do this. Now see in this case, what will you do here? You will again update low to mid plus 1, but doing this you missed 1. Okay, so you will incorrectly return minus 1 because from mid to high you won't find from mid to high, you won't find one, but actually it exists in the array. So that is the reason you will return minus one here, which is wrong answer. So for correctly identifying the sorted range, we need to have some good method. Like we need to see what we can do. So let's see where the problem is actually arising. Like this is your array. Why the problem actually arised? This is your array. Okay. So the problem arised only because, you know, I give you three arrays. This is one array. This is another. What can be the third? Hmm. Okay, suppose these two only. Suppose. Okay. Be carefully here. Like here, the mid comes out to be this element in both the test cases, and we need to find one. Target is one here. Target. This is the target. Okay. So see carefully here. Like in this array, in this part, we can easily find like this array is not sorted. Okay. So this clearly gives us the idea. But here, if you see, in this case, you can't find this array sorted. And why this happened? Because the nums of low was equal to nums of mid. Correct? That is why you wasn't able to find like whether this part is sorted or whether this part is sorted. So that is the problem. Okay. Let me give you another case also like where mid and high would be the problem. Yes, or So suppose this is some test case. Uh, I don't think so. Nice. So I can't think test case. Oh, this some tool. Let me find using this only. Uh, will I remove this? Yeah. So we get this test case. Yeah. So let's see. Yeah. So suppose this is some other test case also. One, multiple times one, two, then one. Okay. So see this case. Like you were thinking like only if nums of low were equal to nums of mid, that was the problem. Okay. So this is one case. And what happens here? Suppose this is your mid. So this is your mid, this is your low, mid, low, and this is your high. Okay. Let's not circle it so that you are not confused. Okay. So this is your low, this is your mid, and this is your high. Okay. And your target is 2 here. So this may the case may occur like this. Okay, so yeah, yeah, this may occur. Okay, so what happened here? Like if you see, like nums of low is equal to nums of mid, but still I'm not able to give you a good example. Mid and high are unequal. Mid and high are equal. Okay, so I think that test case does not exist that I'm thinking. Okay, so this is the problem only. Like the only problem arise in the case where nums of low is equal to nums of mid and definitely nums of mid then will be equal to nums of high. Like when all of these three elements are equal, then we can't decide where to go. Why? Because suppose if nums of mid was not equal to nums of high, then we could simply decide, na, like suppose if this element was less than 2, like this, that condition may never arise. Why? Because, yeah, this may arise. So suppose, yeah, this was the best case I was thinking. So here also, if you see mid and this are equal, but still you can make a decision like whether which part is sorted. So since here you will see, Okay, now see here. This is your low and this is your high. Okay, and what is your mid? Mm, Like suppose this is your mid. Now here also your nums of low is equal to nums of mid. But if you see, using the high, we can make a decision whether mid to high is sorted or not. Why? See here, since this 3 is greater than 2, then we can clearly be sure that this part is definitely not sorted. Definitely not sorted. Why? Because 3 came and after that 2 came. So definitely this part is not sorted. So only, and definitely at every point in the array, either the left half is sorted or the right half is sorted. You can uh, you can think of that for 2 minutes, and you will see like at every index in the array, either the left part is sorted or the right part is sorted. See here, left part, left part, left part, left part, left part, right part, right part, right part. Okay, so each index in the array, at each index, either the left part is sorted or the right part is sorted. Now, since at index 3, even though the left part we couldn't make decision in the left part, can't make decision because nums of low is equal to nums of mid, but still we could make the decision seeing high value, like since 2 is less than 3, so definitely right part is not sorted, so we could make a decision that left part is sorted. So the only problem we are getting in the whole question is how to find which part is sorted. How to find which part is sorted. And this problem is only arriving in those test cases where nums of low gets equal to nums of mid and nums of mid get equal to nums of high. That means all these three elements are equal. Only in those test cases we can't make a decision. See here, like here you couldn't make a decision because nums of low and nums of mid and nums of high, all three were equal. Here you could make a decision because nums of low and nums of mid were not equal. Here also you could make a decision because nums of mid and nums of high were not equal. Okay, so the only problem that arises in the case is where low and high all are equal. Low, high, and mid all are equal. So only that part is the problem. Otherwise, the code remains the same. So in that case, where low, mid, and high all are equal, what we'll do is we'll just shrink the array. Okay, so what we'll do is we increase L, like, so suppose this is your array. Now what will you do here is this is your low, this is your high, and this is your mid. Here low, high, and mid, all three elements are equal. So in that case, what will you do? You will shrink the array. Okay, so this becomes your new low, this becomes your new high. So what happens in this case? Why I'm doing this is because since we know like we need to make a decision at some point. So for finding that we are doing this because we know that this is also 2 and this is also 2. So inside them it won't make any of the difference. Why? Because mid is also 2. Okay. So that is the reason like we can shrink the array without any problem. We are definitely sure at this point because since we need to make a decision like where the answer actually lies, that is why we can shrink the array without any problem. Now, if you see what is the mid here, mid again comes out to be the same. This element only will be the mid. Okay, so again we'll shrink the array low and again this is mid only. Okay, so what happens now? But this time, if you see, we can make a decision seeing this value. Okay, so that is the reason. Like whenever low, mid, and high, all three are equal, you need to shrink your array so that you can come at a conclusion at some point. Okay, that will help you. That is why we are because we saw earlier. Like the problem only arises when low, mid, and high all three are equal. That is why we are shrinking from both sides so that from whichever part either low doesn't get equal to mid or mid doesn't get equal to high, from whichever part we get, even if we get one unequal thing, even if we get one unequal pair, then also we can decide like which part is sorted and which part is not sorted. So that is the reason. And you may be thinking like some case may arise like upon shrinking the array we may miss the right hand side. Like you may think like somewhere low was here, high was here, and this was a huge array. You may think something like this, like this is your low, this is your high. Okay. and this was your high, and apart from this there were several other elements. There were several other elements, and your mid comes out to be here, where all low, mid, and high became equal. Now, don't think like shrinking the array would cause any problem because the answer may lie somewhere here. We are sure that answer won't lie somewhere here. That is why low and high were always in the range. Low and high always remain in those that range only where the answer can lie. Like this is the search space now. How we can make such a state? This state never occurs if this state will never occur where answer does not lie in low to high. If answer exists, then it will definitely lie between low to high. Our search space is such that only. Why? Because initially we started over the whole array. Like initially first element low, last element high. Now we will never update our search space such that the answer lies outside of it. Okay. That case won't ever arise. So don't think about it. So let's see the code. Yeah. So similarly calculate the that mid. Okay, and this is the case. Similarly, if nums of mid equal to target, then you can simply return true. Otherwise, I removed the condition. Let me put it back. If nums of low equal to nums of mid and nums of mid equal to nums of high, that means all three elements are equal. Shrink the array. Otherwise, the similar case, like similar, the code after this is for same from question one. Okay, so yeah, let me submit this. I think this should be accepted. Yeah, so this beats okay. So this is also done. Now let's see another type of question like rotated sorted array was this much only. You can do some more problems if you see, but I found it only these problems. So that is why. Now let's see another class. Sorry. Binary search on 2D array. Okay. I hope you can see it. Binary search on 2D arrays. Okay. So let's read the question. What is the question? You are given a matrix. Each row is sorted in non-descending order. Okay, and the first integer of each row is greater than the last integer of the previous row. Okay, so what the question is trying to say is like you will be given some matrix of integers, and the last integer of the first row is definitely smaller than the first integer of the second row. Okay, so okay, so again you see like this element is definitely greater than 18. Okay, so it may be 19, 20, anything, but it is definitely greater than 18. So yeah, like the array is sorted something like this. Sorted, this whole is sorted, and again from here, again sorted. This part is also sorted. Again this sorted, again this sorted, again this sorted. So this is the way that the whole matrix is sorted. So what we need to do is we need to find an integer target. Like if it returns, if it exists, we need to return true. Otherwise, we need to return false. And the expected time complexity is big of log m into log n, log m in n, log m n. So log m plus log n, you can say. Okay, log m plus log n. This is the expected time complexity. Okay, expected. So this is the expected time complexity from us. All right, so let's see what can be the solution. Since you can see the whole matrix is sorted, so there is some kind of monotonicity. We just need to exploit that. Okay, so monotonicity is there. Monotonicity is there. Just exploit it. So let's see how we can exploit it. Okay. So see carefully now. Like if suppose whatever the target is, suppose your target is 18. Okay. Now if the target is 18, it can definitely lie in this row only, you can see. And because it is greater than 10 and it is less than 20, so definitely it will lie in this like second row only. Similarly, if suppose your target is 6, it can lie in first row only. Why? Because it is greater than 1 and it is less than 7. So for each element, for each target, you can say, each target have only one capable row. Like it can only be present in one specific row only. It won't happen like the case never appears like never there be a case where the target have more than one row possible. Okay, why? Because since we know that 6 can why am I saying like can 12 lie only in the second row? Because the array is sorted, the matrix is sorted. Correct. Why? Because after 7, okay, 10 appears, and you are saying that 12, if 12 won't appear in the first row, then it can appear in the second row. How will that happen? Because the second row already contains all elements greater than 20, and then how it may happen like it contains 12. So there will never be a case where no, this 10 to 20 row doesn't contain 12 and any other row contains 12. So this case never arises. So that is the reason you can think. Yeah. So that is the reason. So what I am saying is 1357. Like suppose this matrix only I just made. Let me complete it. Okay. So what I am saying is for each target, you have only one candidate row. Okay. We just need to find what is the row that the element may be present at. Okay. So I am saying is for each element, you have only one candidate row, and we need to find like what that candidate row is. Why I am saying this? Because see, suppose I say for target equal to 16. If you see, 16 lies from 9 to 18, somewhere from 9 to 18. Okay. And all elements apart from this row are either less than 9 or either are greater than 18. Okay. So this we are sure. So definitely 16 can't lie in any other row. So for each element, for each target, we have only one candidate row. So first of all, what we need to find is we need to find what is the candidate row for that particular target. You are given some target, and for that target you need to find what is the candidate row, candidate or possible row for that element, for that target. How will you find that? Finding that is, pretty easy. What you need to do is simply perform a binary search on row wise. Okay, so this is your row. Okay, so suppose this is your comes out to be your mid, this was your low, this was your high. Okay, so what happens? This is your mid. Simply check for whether the target is, greater than first element and less than equal to last element. Then the target should definitely lie in this row. Otherwise, if the target is less than smallest element of this row, then it lies above something somewhere. And if the target is greater than largest element of this row, then it definitely lies somewhere down. So this is a very simple approach. Okay. So in this way, you can get the candidate row. Simply, it is very simple to get the candidate row. Like, let me show you some example if possible. What is the target here? 13. So again, okay, so this is your low, this is your high, this is your mid, and your target is 6, suppose. So what happens? You come at this mid, you check whether 6 lies between 10 to 18. No, it does not lie. Is it less than 10? Yeah. So definitely it lies somewhere above this row, somewhere above this low. So we update high to mid minus 1. Now this is your high and this is your low. So your mid comes out to be this only. Now we check whether 6 lies between 1 and 7. Yeah, it lies between 1 and 7. So definitely we have found our target row target row in big of log n time. Okay. Now simply apply. Now you have a single array. Suppose this becomes your array. Now you don't care about rest of the matrix. This is your array, and you simply need to do a simple binary search just to find whether a given target exists in this array or not. So this becomes now a 1D array. So what we did was we first simply see only the row parameter. Then we come on the column parameter. So big O of log n for just finding the candidate matrix, and another big O of log m because the number of columns are log m for finding whether target exists in that or not. So in total, the time complexity becomes log n plus log m, and that comes out to be big O of log m into n, m into n. Okay, so this was expected, and we approached at this only. So let's see. Yeah, so initially low equal to 0 and high equal to n minus 1. If the target element is less than the greatest element, okay, yeah. So, yeah, if the target is greater than the largest element, the target is greater than the largest element of the current row, the mid row, then definitely target lies in some other row downwards. So we do low equal to mid plus 1. Otherwise, if the target is smaller than the smallest element of the current row, then definitely the target element lies in some row upwards. Okay. Otherwise, simply store answer in low because this is the candidate row only. So we do low equal to mid and do break. So we store the candidate row in this variable row. Okay, and now simply do a binary search on column. So low equal to 0 and high equal to m minus 1. So if you find the target, return true. If the target, you can, you have seen this part several times. Like this was the first class only. So you can, I think you may know this much. Okay, so for today, I think this much is okay for today. Okay, so yeah, thank you.